polynomials. Okay, so before going to class 10th polynomial concepts, I would like to ask you people, because you must have studied this concept early in your class 9th. Okay, so there are of course important concepts. You may look after or look those things or go or recall those concepts. What a polynomial is, what is a polynomial, and what is called degree of a polynomial, what are the coefficients of a polynomial, and yeah, all those things when a certain equation is called polynomial, and what is a factor theorem, and what are the algebraic identities, what does it mean by equation to be identity. Okay, so all these things you can go back and look after. Okay, so if you have any doubts regarding these things, regarding the concept you have learned in class 9, you can ask me. Okay, and let's start writing a polynomial, general polynomial. Okay, so we denote polynomial of px or p of x. X here is a, you can say, variable. Okay, so we have to get this a n x of n plus a n minus 1 x of n minus 1 plus dot 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 plus a 2x2 plus a 1x plus a 0. Okay, where a is equal to 0. Okay, so if a is equal to 0, it's called any polynomial. Okay, where n are positives and r positives. Yes. Okay, this is general definition of a polynomial. Okay, let's say if n is equal to 0, what will happen? If n equal to 0, then p of x will become only a0. This is 0 polynomial. Okay, 0 equal to 0 polynomial. a1x plus a0, this is all linear polynomial. Linear polynomial. When n equal to 2, px will be like a2x square plus a1x plus a0, so it's a quadratic polynomial. Quadratic polynomial. And then cubic polynomial for degree 3, and it's n degree, for degree 2 it's called quadratic, for degree 3 it's called cubic, and so on. Okay, so these are the simple definitions of polynomial. If you know this much, I think you are good to go, and you will have easy time understanding the ongoing or the upcoming concepts. Okay, so this is about polynomial initially. Now tell me, what would be the necessity to have this concept? Again, I am asking this again and again, because before understanding a concept, we need to know what need must have inspired us to look for this concept. This is a central thing which actually inspires us to know more about the concept. Did we started it randomly? What was it? So I wouldn't say it was random, because we did have some kind of identities, we did have some kind of equations where we use some variable to find the value of a dependent one, right? So that's why it was a formalization of those random things. Like if we say speed equal to distance on time, okay, there are both variables. Okay, we can write distance equal to speed or time. If we constant speed, then distance is the time dependent, means it is a, now it has become like this one, as t plus some a0, you can take it this way, a1 and a0, where a1 equal to s and a0 equal to 0. So now this equation, right, these things were of course existed before, but their concretizations or their more formalization was the need of the hour to get these things on the table. Okay, p of x equal to something is there, let's say g of x. Okay, or let's make it a bit concrete, ax plus b is a linear polynomial. Now how do we know what are its zeros? How do we know how many zeros this polynomial has? ax square plus bx plus c. So actually, on which factors or factors zeros of this polynomial depend. If we give some values these constants, we can get what are the zeros of these polynomials. But does the zeros of these polynomials have some geometrical graphical representation or geometrical significance? Can we represent them on a graph so that we can say, okay, this zero is like this is a natural thing, x13 was body, this is also called x13. Okay, so yeah. Now this is a straight line. Okay, this is a straight line. What does it mean that x equal to x0 is a zero? A zero of, let's give it a name, p1 of x. What does it mean? It means when we put x equal to x0 in p of x, in this polynomial, okay, we get zero value. Means we get value of p of x as 0. That's what it means, that x0 is a zero of this polynomial, right? Means substituting x equal to x0 in this equation or in this polynomial gives us a return or outcome of 0. So in this fashion, if I put here, I will get from here x0 equal to minus p by e. So this is the value of x which will make this equation equal to 0. But what does it mean? Okay, I found what the zero of this polynomial is. Same thing I can get for this. Okay, but what does it mean? It simply means that this equation which actually intersecting this line, this is a dependent, we can write it like this, y equal to ax plus b. So this is a intercept. It will be like if we want to find this, how exactly we will draw this. So we can write here y equal to bx plus c. When we write, this is x-axis. So on this axis y equal to y will be 0, and on this is called y-axis. On this axis x will be 0. So if I want to find where this line cuts y-axis, what I will do, place x equal to 0 in this equation, I will get that y will be, okay. So at x equal to 0, I get y equal to c. Okay, actually, yeah, so b. Okay, so I get x equal to b. And on this axis, where this line intersects, this axis if I want to find, what I will do, put y equal to 0 on this equation. So I get what? U plus ax plus b. I just get x equal to b upon minus b upon c. So I got 2 points. One is like 0 upon b, and the point is minus b upon a comma c. These points are the intersecting point of this line with the x and y axis. So what I will do directly, I just assume that this is 0 comma b, and this is somewhere here. This is minus b by a upon 0 upon 0. Now I just join these points. Okay, let's see. So this is the line where this line intersects. We draw this line on fraction. So what does it mean? 0 of this line are the point of intersections with x-axis of this line, right? As many points, as many times this line intersect, or this curve, this polynomial intersect x-axis, we call as much zeros it has. So how we will get that? From the degree of this, means how many x values we are getting, right? Means if one value I am getting from here, one value of x. Okay, why? Because we have 1 degree. This is a linear polynomial. Here we will get 2 values of x. How? Why? Sometimes it could be the possible, means it could be possible, of course. It could be the thing that we get both the values same, or yeah, more than one value same of those of polynomial, right? So in this case, we can see we will get 2 values of x. So it will have 2 zeros. So it will be like, we can say it will be intersecting either this way, okay, or either this way. It could be anywhere, okay. So what does zeros of polynomial mean? It means the polynomial as the equation intersects that many times to the x-axis of the Cartesian plane. Now you tell me, I have 3 to 4 graphs, let's say. A, B, C, and D. 3 graphs, okay, 4 graphs, and there are course polynomials. Now you tell me, how many zeros this one has, what about this, what about this, and what about this. So if you can see, you can of course pause the video and check, try to figure out, and then you can see the answer, okay. Okay, so this graph you can see cuts the x-axis. Beside the number of zeros are the point of intersections a curve has with x-axis. So 1, 2, 3, 4. So it has 4 zeros. How many zeros? 4, right? What about this? This curve intersects x-axis at 2 points. Okay, so it will have zeros equal to 2 number of zeros. Okay. And what about this? This curve never seemingly, of course, I don't know if we like stretch it more or see its full extension, what is the situation, we cannot predict that, but whatever data we have been given here, or the graphical representation we have like provided here, from that we can say it has no zeros. And what about this one? It has 1 because it touches here, and here we can say 2, 1 and 2 because it is intersecting some way. So number of zeros will be 3. So in this way we can say how many zeros a curve have, we can get that, okay. So this is what about zeros of a polynomial. Now we will find a relation between zeros of a polynomial and its coefficients. So before starting, I'll give you I'll start with a simple example or simple case. I would say that's a polynomial of degree 2, right? So it's a polynomial. Let's say p of x equal to ax squared plus bx plus c. It's a 2-degree polynomial. We also say it or call it quadratic polynomial. Okay. So let's say it's before like starting that a, b, c. It's a quadratic polynomial. So a cannot be 0. Okay. A and c are coefficients. Are coefficients. Okay. So these are coefficients. Okay. And now we'll assume, suppose alpha beta are zeros of this polynomial. Let's say give it a name 1. Equation of are zeros of p of x. What zeros mean of polynomial? You must have learned in class 9. If x equal to alpha is 0 of p of x, what that means? It means x minus alpha and x minus beta. X minus alpha and x minus beta will divide what? Will divide p of x. This is what the factor theorem says, right? It means x minus alpha into x minus beta also divide p of x, right? Exactly. But the multiplication is a 2-degree polynomial. If you multiply this, what will be? It will be x squared, multiply this, and minus beta x, it will minus alpha x, it will minus plus alpha beta x. This much will divide p of x, right? But this is 2-degree polynomial. and this is also 2-degree polynomial. We can express p of x as some factor multiplied by this polynomial. That is fair enough. Okay. So now what we can do, we can equate this much with this much very easily, because this is px equal to, we got from here this, and we already have px equal to this much. So now we can equate these two equations, this much with this. Okay. So what we will get here, ax square plus bx plus c. Then let's multiply here, which will be x square minus k times alpha plus beta x plus a alpha beta, and compare these two things. What we will get, k equal to a minus k times alpha plus beta equal to b, a alpha beta equal to what, c. Now we substitute k equal to a. So if you will a times alpha plus beta equal to b, so we can do this alpha plus beta equal to minus b by a. And yeah, we also have a alpha beta equal to c. We can substitute a in place of k, substitute a alpha beta equal to c, so alpha beta equal to c by a. So these are the relationship between zeros of a polynomial and its coefficients. Okay, these are coefficients a b c are coefficients of this polynomial, and alpha beta are zeros of this polynomial, which is supposed. Okay, so in this way we can say sum of the zeros of a polynomial is equal to minus b by a, and product of zeros of a polynomial is equal to c by a. So this is a standard relationship, alpha plus beta equal to minus b by a and alpha beta equal to c by a. How we drive this relationship? You can also drive this relationship for other kinds of polynomials, for polynomials of high degree. Okay, so yeah, you of course can do with similar fashion. Okay, so yeah, if you have any doubt you can ask me, and then I'll move forward. Now I'm taking a question where you have to find firstly the zeros of a polynomial. Okay, and then you have to verify that. Okay, so it's like a 6x minus 3 minus x is equal to 0. Okay, you have x equal to this polynomial. Now you have to find its zeros. What will be its zeros? Then you have to check whether the relationship we have just found or derived is right or not. We have to check. We have given two parts. Okay, firstly what we will do, then it is their method. It's called factorization. You must have learned this also in class 9. So we will use that, just do that. Okay, that is why we will write in standard form. Now what we do, can we multiply these two and then factorize this as a sum of the which can help us to factorize it. So firstly what we do there, we multiply the coefficient of the highest degree, that's 6, and the last one 3, it's a 18. Okay, now this sign, we use this sign as an indicator, as a guide. How we have to get this number, by subtracting the two factors, okay, of this number. So what will be that? We can 9 and 2. 9 2s are 18, right? And we have to find here minus 7. When we get minus 7, when we subtract 9 from 2, means 2 minus 9 equal to minus 7. We can do this here. So 6x square minus, or we can say plus 2x minus 9x minus 3. Okay. So now if you take common out, then we will do 2x and divide by 2x and we get 3x, and we will have a plus 1, and then we from here we can take common out. So minus is common plus both terms, so 3 we can take out and we 3x minus plus 1. So this is, and now we can take these are two terms, we can take x plus 1 out and we can get this plus. Okay. Yeah. Now we got two factors of this one. We have factorized this. Now if it is, let's say we have to find the zeros of this polynomial. For zeros of px, what we have to do, we have to put it to 0, equal to 0. We have to make p of x zeros, its value is 0, right? So we will do this thing. And now we can put from here 3x minus 1 equal into 2x minus 3 equal to 0, right? When this whole term will be 0, when either of the terms will be 0 or both of the two terms will be 0. So we equate both the terms equal to 0, and we take this one here to be minus 1, and we divide it by this to get this one, right? And the same goes here, 2x minus 3 equal to 0. When we take it here, so it will be plus, and divided by 2, so it will be 3 by 2. So these are two zeros of this polynomial, right? Now we have to verify that relations. We can call it alpha and call it beta for your understanding. Okay, relations between zeros and coefficient of polynomial. What is that? Alpha plus beta equal to minus b by a, and alpha beta equal to c by a. Right? So alpha beta, first we will find this one. So alpha plus beta equal to, for this question, minus 1 by 3 plus 3 by 2. Take as the denominator 6 minus 2 and minus, that's a 9. How much it is? 9 of course. So it's how much? 7 by 6. And now find minus b by a. Let's say what is b? Here you can say b equal to, I can write here a equal to 6, b equal to minus 7, and c equal to minus 3. Right? Okay. So minus b. Minus is minus b is equal to minus 7 by a 6. So it's minus after 6 by 6. Just same. Both are same. So it means alpha is equal to beta. Okay. Next round. Alpha beta. Alpha is like minus 1 by 3, and we can beta is 3 by 2. So when we take these two things, 1 and it will be minus 1 by 2. Right? And what is c by a? C by a is like c by c. C minus 3. What is a? A is 6. So it will be minus, and we have to divide this one, we get this minus 1 by 2. Okay. So the result is same. We can say this c by a. No worries, alpha beta. Yeah. So these things are the same. It means our zeros, all the relations between zeros and coefficients of a polynomial is valid, right? So that's what we have to show here. Show this here, and we did it. Okay. And yeah, that much you are asked asked when you are given sum of zeros of polynomial, say alpha beta is equal to given 1 and alpha beta is also given 1. Means sum of the zeros of a polynomial are given 1 and product of the zeros of a polynomial is also given 1. So you are asked what will be the equation of the polynomial, right? Very simple. What is the equation of polynomial in terms of roots? It is x square minus alpha plus beta x plus alpha beta. This is the equation of polynomial in terms of its zeros, right? So in that case, what will be this? X will be same, minus will be same. What is alpha beta? It is 1 into x, that is 1. So after simplifying it, we get this much. So this is the result polynomial if zeros, if the sum of zeros and product of zeros of polynomial is given. Okay, so or are given there. Okay, so these are the things. This is the only thing you get in our syllabus regarding polynomials. But you have to remember things which are you were taught in class 9th, because those are fundamental things which you will take forward to learn these concepts. I hope you enjoyed this session. So thanks for watching.